Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Engineering. So in this session, I am going to discuss about the essential components of laser, resonant cavity, types of laser, and then India laser. So what are the essential component of laser system is active medium, we need a pumping mechanism, and then optical resonator. So already we have discussed about the pumping mechanism. So what is called active medium? Active medium is the material which we are taking for that particular laser and where that population inversion takes place. That is called the active medium. And optical resonator, or that can be called as a resonant cavity. This is also important component, so which will helps to amplify the laser source. So here we can have two parallel mirrors that can be placed around the active medium, and with the help of this resonant cavity only the light can be reflected back to the medium and get amplified. Next is the types of laser. So based on the material chosen only it can be classified. So the first one is solid laser. Example is NdOC. Liquid laser rhodamin. And gaseous laser we can have a carbon dioxide and helium neon laser. For dye and chemical laser we have a polyphenol is the example. And semiconductor laser, here we have a homo junction and heterojunction semiconductor laser. So in this we are going to discuss about NdOC, CO2 and semiconductor lasers in detail. The first one is the NdOC laser. It is the example for solid state laser or a 4-level laser. So for learning every laser, if we know the characteristics well and clear, means it can be easy to explain that entire laser easily. So the characteristics. The characteristics, we have a type, active medium, active center, pumping process, optical resonator, power output, nature of output and wavelength of output, and then what would be the wavelength nature, that is nature of output. So here the type is doped insulator laser. This is the type of NdOC laser. And then active medium is yttrium. So yttrium aluminum garnet is the active medium, but active center is neodymium atom. So active center is nothing but neodymium atom. And pumping method is optical pumping, and pumping source here we are using the xenon flash lamp. And optical resonator, that can be the end of the rod can be act as the optical resonator. Power output is 20 kilowatt and nature of output is pulsed and the wavelength is 1.064 micrometer. So the principle is nothing but yttrium aluminum garnet that is doped with the neodymium atom. Here the neodymium atom have a n number of energy levels. So due to that energy levels we can have a transition for the laser action. So this picture shows the construction of this NdOC laser. So here we have a elliptical cavity. In that we have laser rod. That rod is made up of yttrium aluminum garnet doped with the neodymium atom. And flash lamp also placed here. Here we are using xenon flash lamp, and that is connected with the capacitor and resistors which can control that flash lamp. And both are placed in the elliptical cavity, and the end of the rod will act as the optical resonator. And apart from that we are having two mirrors here, that is 100% reflecting mirror and partially reflecting mirror here. And working is nothing but if we switch on that flash lamp, that light will be absorbed by the atoms present in the laser rod, and that moves from the ground state to the excited state. Here the neodymium atoms moves from ground state to excited state. Here we have the energy level diagram for this. So first neodymium atom by observing the light energy moves to E2 and E3 energy level. So once the atoms moves to the excited state, that cannot be stay for a long time, that won't come back to the ground state. So that transition from E3 to E4, there is no radiation emission, that is called non-radiative decay. So from E4 to E1, we'll have a transition, and during that the laser light can be emitted, that is 1.064 micrometer. And again the transition from E1 to Z0, we have again non-radiative decay. So from the transition between E4 to E1 only, we are having the laser light of wavelength 1.064 micrometer. And what would be the applications of this Antioch laser is the transmitting the signals for longer distances, and it is used in long haul communication system and endoscopic application and remote sensing. So this is the solid laser, and we'll continue in the next session with the different types of laser. Thank you.